Hi folks, welcome back to the shop here at Project Pine Hills. Today we're talking about this Vessel ball grip cordless screwdriver. You can see it has USB-C charging. There's 3 different speeds here. You can freeze frame and check those out. The part number is 220USB-P1. And you can see here that it's made in Japan. Take a quick look at the side here. You can see it has a different type of cullet on it. We're going to talk about that, but it's designed to take these 13mm anvils, and it has a 6.35mm cullet. That's just a 1/4 inch cullet. We're going to talk about that. There's a quick look at the back that can show your typical uses. All right, let's take a quick look at this screwdriver. You can see the screwdriver handle is kind of made of what looks like to be a fiberglass infused polymer. They got Vessel stamped right here on the side, and they have this nice rubber overmold over the screwdriver and the ball grip. Take a look around here at the other side. You can see they have written right on here, it's rechargeable ball grip. There's that part number again, that 220 USB-P1. And right there is the RPMs. It's 280 RPMs on low, 340 RPMs on medium, 400 RPMs on high. It's got a 3.6 volt or a 4 volt lithium battery in it. There it says Vessel Co. Inc. Made in Japan. Here's the switch to operate the screwdriver, and we can change the speeds by pressing on this button right here. It has a green light in it. If I press this button down, you can see I get a slow blink. That means it's on low. If we press the same button again and hold it down, you can see it gives a faster blink. That means it's on medium. That's that 340 RPMs. Then if we press it down and hold it again, and it goes solid, that means it's on the fastest setting. That's 400 RPMs. And that's, of course, where it has the most torque. If we look at the end of the screwdriver, you can see that there's a recessed hole right here on the side. That's for a lanyard if you want to put a lanyard on the screwdriver. Over on this side, we have a cover here for the USB charging. If we open it up, you can see there it has USB Type-C charging. So if we go ahead and plug it in, I'm going to plug it in here, and you can see that the LED light turns red when it's charging. So this is a regular Vessel 230W tang through screwdriver, and you can see how it compares in terms of size. We put these side by side. You can see the ball grip on the cordless USB screwdriver is just a little bit bigger. There they are side by side. Now you control this screwdriver with this red slider switch. Now this is the Japanese version. It's red. On the US version, it's blue. You push forward to tighten, and you pull back to loosen. And I like the fact this is a slider switch. Once you get positioned, you just move forward and back with having to lift your thumb and find the switch. Another thing about this Vessel is you'll notice it has a raised switch on it. So if you're trying to find the switch on the screwdriver in a blind spot, you can articulate it and feel it just by hand where the switch is at, and you don't have to reposition your thumb. On this Craftsman, for example, the switch is flush. If you don't have visibility, you have a much harder time finding the switch, and you have to reposition for the switch on the Craftsman. So this Vessel is more intuitive. You also notice there's a light here on the front of this Vessel. And you can see it has a red sort of ring here at the top that goes around the screwdriver. Some red here to cullet. Now the cullet itself here, you pull up to release or put bits in. Now this Vessel screwdriver comes with this JIS bit. And the JIS is referring to the type of tip it has on it. It looks like a number 2 Phillips, but it's not. JIS stands for Japanese Industrial Standard, and you'll notice it has a longer anvil down here than a US screwdriver. If I put this Milwaukee here beside it, you can see a difference in the size there, that this is the US standard and this is the Japanese standard. Now this is the Japanese domestic market version. That's why it has this Japanese cullet. They just came out with the US version, but it costs a lot more, and it doesn't really fit the bits very tightly. I'll have a link in the description. You can check it out. So if I take this screwdriver and I pull up on the cullet and I insert this bit, you can see how it fits in there. Pretty good fit, pretty typical. Now this has a JIS bit on it, but it will fit a number 2 Phillips perfectly. You can see I can put it right on this number 2 Phillips, and it fits perfectly in there. Very snug fit, so it'll work perfectly fine on Phillips number 2 screws. But if I take this out, and let's say you want to put a US bit in here, and I have this 6-inch Milwaukee I'm going to put in here with that smaller anvil, you can see it goes in there, and there's a fair amount of play. For some folks that might be acceptable, I don't know. But what you can do is they make this spacer for this screwdriver. You can see here, I'll have a link to this in the description, but it's a spacer that's got this cone on it. So the cone that this spacer has on top is exactly the shape that's inside of the cullet on this Vessel screwdriver. All right, here we can see the Japanese JIS bit side by side with a US style Milwaukee bit. And I put the spacer here on the end, this Makita Punta spacer that I'll have a link in the description for. You can see how the spacer adjusts the length of this USA style bit to make it fit in the screwdriver. So you can just take this spacer here and you put it right here in your screwdriver. You put the pointed tip down, right? So I put the pointed tip down in there. You see it slides in there. If I pull up the cullet, it'll fall the rest of the way down, and it won't fall out now. And now if I take this US bit and I put it in there, and you can see that there's a lot less play with this US bit. Now if I want to remove this bit, I can take it out, and you can see that spacer stays in there. It won't fall out unless I lift it up and make an effort to actually have it fall out. So it stays in there pretty well. So this is one option you can do if you want to run this Japanese screwdriver. And like I said, they do have a US version with a US cullet. There's quite a bit of play in it, and it's talked about over on Morgan's Maintenance YouTube channel. You can go check it out. But to me, that's too much play. Plus, you also get the advantage of taking the spacer out when you want to and running Japanese bits. You have that option. And the other benefit is you can take double-ended bits, like is on this Annex Japanese screwdriver made in Japan as well. You can see it's got these double-ended bits, and if you look at it, you'll notice it also has a longer anvil in it, that 13 millimeters right here, and I can take that and put that in the screwdriver, and of course it fits in there fine. So you have that option as well. So with the Japanese version, it costs a lot less than the US version. It's exactly the same otherwise. As long as you have this spacer, and I'll have a link in the description, that means this can run either US made bits or Japanese bits. Take your pick. So like I said, it does a really good job of staying in there. I can have it sideways and take it out. It doesn't fall out on its own. And you can buy these spacers in a 2-pack, or if you want to, you can make your own spacer by cutting off this part of a US bit and then grinding it down, getting it just the right size, where you could use that as a spacer instead of buying one. So you have those options. But this is made for the Japanese market. This particular screwdriver, again, it costs a lot less than the US version. Now, the US version does come with bits. Now, this is a 4-volt screwdriver, and it does have an 18350 battery in it, just like the one I show here. Right here in the ball grip is where the battery is. That's how it's powered. These screwdrivers are designed for threading screws that already have a threaded hole to go into, whether it be wood or metal. If it's wood, you have a piloted hole. If it's metal, you have a threaded hole, a machine screw that you're using. That's the idea. It won't over torque. You don't want a lot of torque with these. Now, previously on this channel, I've talked about this 4-volt Craftsman screwdriver, and I've used this for some time. And same thing, it has a cullet on it. You can pull into the screwdriver and you put your bits in. Of course, see, it won't fit that Japanese anvil, but it will, of course, fit the US bits. So I can put that in there. You can see the fit has about the same play that you have on this Vessel screwdriver. This one has about 300 RPMs and has a good life, and it's a good screwdriver. The best thing about it is, over this Vessel, is it has this light on the front end of it. It's got 2 LED lights, really well lit on the front end, and this is a good screwdriver. It works great, but it won't over torque what you're working on. But both of these are 4 volts, okay? And you have other options. This DeWalt is an 8-volt screwdriver, and as you go up in the voltages here, the torques increase, of course. And over here I have 12-volt tools. So this is an impact driver, which is a whole different tool, right? It's designed to have a tremendous amount of torque. But we're not looking for that from this Vessel or from this Craftsman. We're looking for something that threads a screw, and actually it's good that it has lower torque so it won't over torque what you're working on. But both have those 1/4-inch cullets on the front. They work a little differently. This one pulls back, this one pushes forward. Now if you compare these two, now this Vessel I have it on medium right now, but you can see it starts really fast, stops really fast. The Craftsman, kind of slow to start and slow to stop. Actually sounds like it's faster in reverse, but you see it's slow to stop. Vessel almost has like what feels like a brake in it. Now, one thing about these screwdrivers is they have a spindle lock in it. That means that if I want to run this screwdriver just like a manual screwdriver, I can put it on here and turn it without using the electric motor on it. And you can see here I can turn this screw manually. This Craftsman has the same feature. If I put it on here and I start turning it, now you heard a little bit of gear spinning there, but now the spindle lock's engaged and I can turn this manually. You can see that. Now if I go the other direction, come back, you'll see the gears turn a little bit. Yep, there they turned a little bit. But overall, it works pretty well. If you're turning in one direction, that spindle lock will kick in and it'll work. It's great for starting screws or getting them tight right there at the end. You don't want to over torque them. You can get that manual screwdriver feel, right? So you can take this down, get it tight, and then do that final turn manually with that spindle lock that's in here. But I did notice that the spindle lock works better on the Vessel. That Vessel spindle lock, it kicks in immediately. And when I go both directions and I switch directions quickly, the Vessel spindle lock does not loosen up. You never hear the gears spinning. Let's look at the play in this Vessel screwdriver. If you look at this Craftsman screwdriver and we just turn it until it engages, you can see the play it has in the driver. If you look at the Vessel, it's got a lot less play than the Craftsman. Now let's demonstrate how this Vessel screwdriver works. You'll see I have 2 pre-drilled holes here that I've just started to screw in. So I've already drilled these 2 holes out. I've just kind of started them in here, a few threads in. Now let's just do a quick comparison here of how these 2 screwdrivers go. Now if you look at this Vessel, you'll see it's got a solid green light. That means it's on the fastest speed And the fastest speed has the highest torque. The lowest speed has the least amount of torque. So we're on the fastest speed with the most torque. We'll just see how it does on this pre-threaded hole for this screw. Okay, and it stops. You see I got a quick red light there. I'm going to back it up, do it again. And stops there, quick red flash. But that's what we want. We want this screwdriver to stop and not over torque, because usually, again, you're dealing with pre-threaded screws. So I'm going to do this other screw here that we have, and also a piloted hole with this Craftsman. And you can see how that one did. They have about the same amount of torque. I know that it appears the Craftsman went down further. Now, by comparison, if we grab this DeWalt has more torque. That's by design, and it goes up to 430 RPM. And now if we take this DeWalt, and I can just push the bit in here in the color, I don't have to lift up on it. You'll notice that I can drive these screws. Now this DeWalt is gyroscopic, which means I'm just going to put it in there, press the button, and turn the screwdriver. There you go. See, it goes all the way down. We'll try it on this other one here as well. See how that does there. In fact, I can also turn this into a pistol grip, and we can do that with the DeWalt. It stopped. But I can get it to go on down. So this is more for cabinet installation or hanging sheetrock, something like that. Something where you need more torque. That's the design of this screwdriver. And of course, if you look at this, you'll see it's 8 volts versus 4 volts. And they're really for different types of work. And I just want to illustrate that, right? You can see that there's more torque with the DeWalt. All right, let's look at how these two screwdrivers do on a hole that's already been threaded. You can see the vessel is faster at that 400 RPMs versus the 300 on the Craftsman. Let's back this screw out. So you can see here that this vessel, just like the Craftsman, automatically stops once it reaches full torque. That's nice to not strip out the head of the screw or the threads of the screw. All right, let's see how well this vessel does at drilling a hole. I've got a 1/8 inch hex style drill bit here. Just pop that in here. Let's see what we can do here. Not that it's designed for this, but let's see how well it does. Of course, you don't want to push down on it too hard. You can see it works just fine for that. As I said before, between these items, you have 4 volts, 8 volts, 12 volts, all increasing in power. And of course, you could go up to 20 volts and have even more power. But again, that's not the intention of these tools. It's got a better spindle lock on it. The motor engages faster and stops faster than the Craftsman. All around, this vessel, to me, is a higher quality tool. Plus you get those 3 different speeds you can choose from, and everybody's going to have their preference. I know a lot of folks are going to want that fastest 400 RPMs. If you like ball grip screwdrivers, and I do, I like the feel in the hand. You like vessel, to me this is the best cordless screwdriver on the market for driving pre-threaded screws. So if you're working on door hardware or like doorknobs, electrical work where you're working with machine screws, you know, this is really the way to go. You need more torque. Again, drywall or cabinet work, things like that, where you need a little more torque. And plus, this thing has a 15-position clutch on it as well. You know, that's a big benefit on this DeWalt. Also has this LED on the front end, but it's a bigger driver overall, right? Doesn't really necessarily fit in your tool pouch as well. And it's really more than what you need to take out machine screws and things like that. But an excellent tool if you're looking for torque and doing installations and things like that. And then you have something like this Impact from Milwaukee. Now this is a whole different type of tool. It's 12 volts, has 3,200 RPMs, and it's 450 inch-pounds. So this is a completely different tool for a different type of job, but a very handy tool nonetheless. I'll have a link to that in the description as well. If you're thinking about getting a cordless screwdriver, again, for finished screws, pre-threaded screws, that sort of thing, these are really both great options. They're priced right now about the same, and for me, I would go with the Vessel. You know, that's, to me, is the way to go. If you happen to find this Craftsman on sale, you know, and can get it for less, well, then I think it's a good choice as well. It's served me well. But this Vessel really is a better built screwdriver, whether you're talking about the type of polymer they used, how the switch works, and how quickly it ramps up and down, how well the spindle lock works when you're turning a screw manually, the overall feel of this ball grip, and the fact that you have 3 different speeds. I mean, the Vessel really is tough to beat. Not to mention the fact this is USB-C, right? This Craftsman's micro USB still. Really can't go wrong with this Vessel. I think it's an excellent tool. I'll have a link in the description. So let me know in the comments what you think of this Vessel ball grip. Do you already own one? Let me know what your favorite cordless screwdriver is if you already have something else. And please remember to like and subscribe. All those actions help me to continue to bring content to you here on the Project Pine Hills channel. And with that said, I'll catch you in the next video.